Hello. In this video, we are going to go over graphing reciprocal trig function. These have the same style and the same method that we do just graphing regular trig and one extra step at the end. So as we recall, we must remember our formulas in our setup. A sine b of x plus c, let's make sure that's an x, plus d. A is equal to our amplitude, a plus minus amplitude. Our period is equal to 2 pi over b. We will then find our increments, which is just the period times 1/4. Next, we will see we have period, amplitude, then we'll do phase shift. You remember what phase shift is, negative c over b, and then vertical shift. And that will just be whatever d is and keep the sign. So we're going to graph this absolutely normally like a sine graph, and then we'll do one extra step at the end. So the first thing we need to do is start labeling what everything is equal to, and that is, we'll start. So first thing is we see that our amplitude is equal to 2. Next, we are going to find our period. Our period is 2 pi over b, and this is my b, 2 pi over 2. So my period is just pi. We then find our increments. Our increments will be pi times 1/4, or pi over 4. That's how much we're going to jump from one point to the next. Next, what we see is our phase shift. And what we see in our phase shift, it is negative pi over 2. This is also the starting point, our phase shift, our starting x-axis point. Next, we have a vertical shift, and we're going to go up 2. Cool. Now that we've done all of that, we can now start to graph. All right. So the first thing we can write down is our vertical shift. So our midline moved from 0 to 2. Here's our 2. Here's our 2. And we're going to draw our midline there. I draw a dotted line just so I can show myself that is our midline. Next, we're going to use the amplitude to go above the midline 2 and below the midline 2. So we go up 2 to 4, down 2 to 0. We're going to draw some more dotted lines because that is our restricted on the wavelength if it was just sine and cosine. But that's how we apply our amplitude. All right, next we need to start with the phase shift and find all other points that will be on this graph. So the first thing we're going to do is we're going to find our points. So points here, or x-axis points. So we're going to start with, again, the phase shift. That is the starting point. That is our starting. I don't really like the orange. We're going to go to a different color. So we're going to do points in red. So we start with our phase shift. This is our starting point. Then we combine our increments and we add them to that phase shift to find that next point, which is pi over 4. So we do negative pi over 2 plus pi over 4. Make sure you change your denominators accordingly. And we can clearly see that negative pi over 4 is what is the answer to that. That is our next point. Then we're going to find the next point. Negative pi over 4 plus pi over 4. Oops. Is just 0. That is the third point. We need 5 total. 0 plus pi over 4 is just pi over 4. Fourth point. Now we find our last point. Pi over 4 plus pi over 4 is going to be 2 pi over 4 and simplified to pi over 2. Those are our points. So now we're going to put those on the x-axis. I can see that this is going to be, so we're going to jump every 2. just to make it a little easier to see. I'm going to jump every 3 because it's a little tight there. So 1, 2, 3, 1, 2, 3, 1 here. You also have to make sure you put those in scale, like it's scaled correctly. As in, if this is 1/4 and that's 1/4 and that's 1/4 and that's 1/4, I can't put negative pi over 2 here and pi over 4 here, then over there. Doesn't make sense. So the scaling must be accurate based on how many negatives and positives you have. So now we write down the points that we found: negative pi over 2, negative pi over 4, 0, pi over 2, and pi over 4, and pi over 2. And then what you're going to do is plot those points accordingly. This is a sine graph. So we start at the midline. It is positive, so we go up. Then the next point brings it back to the midline, all the way down to the lower amplitude, back to the midline. Draw a dotted line. This is your sine graph, if you remember. Now, the only extra step we need to do here is draw vertical asymptotes every time our graph has a point at the midline. So we'll have 3 asymptotes in this equation. Now we are pretty much done, and you are going to graph every time a point hits the amplitude. That is when we draw the opposite of it. We do a little U, we do one there and do one there because that's where it hits the amplitudes. That is your reciprocal cosecant function, the purple graph there. So as you can see, the process remains the same. We do everything the same, and then just draw this extra asymptotes and draw the graph outside of the amplitudes rather than inside the amplitudes. If you have a specific question you'd like me to cover, please feel free to just email me a question. Other than that, I hope everyone has a great rest of your day. Thank you.